Did you ever wonder how autonomous driving can be safe? At the ADA Lovelace Center for Analytics, Data and Applications, we investigated several strategies for making artificial intelligence a safe and trustworthy driver. We use autonomous driving as an example of creating dependable AI by creating reinforcement learning methods for driving assistance. In reinforcement learning, an AI agent is learning behavior from experience. In this case, this means driving around for thousands of hours in a simulator like this. The agent performs actions such as accelerating, braking, changing lanes, and making turns. It observes its environment and gets a reward that tells it how good the result of its behavior is. In the paper, How to Learn from Risk, Explicit Risk Utility Reinforcement Learning for Efficient and Safe Driving Strategies, we split the learning into two artificial neural networks. The utility network, shown on the left, learns how practical a particular action is. That means how fast it gets the car to its goal. The risk network, shown on the right, learns how risky an action is, which indicates how likely it is to cause an accident. Both are combined with a weighting factor to select the best safe action. Both networks and the weighting factor are learned in simulation while driving. Here we see the trained agent driving around a course in a city. On the top right, the actions are visualized as colored polygons. Different speeds, turning left and right, and braking. When an action turns red, the risk network prohibits the action from being taken as it is too dangerous. If it turns dark green, the utility network says that it is very efficient to take. The chosen action is visualized by framing the polygon. On the left, you see the car driving. The other vehicles are colored according to a technique from explainable artificial intelligence, showing how relevant an individual car is for the risk network. To make our agent's behavior trustworthy, we went one step further in the paper, Can You Trust Your Autonomous Car? Interpretable and Verifiable Safe Reinforcement Learning. Once a behavior or policy is learned by an artificial neural network, we use that trained network to train a decision tree by imitating learning. In this step, we make sure that the tree policy is at least as safe as one of the networks. This decision tree policy is then used to drive the car. It is easier to interpret, but we can do even more. By translating the tree and environment into formal logic, we can prove the safety. Now let's see such a tree policy drive our car. Here we see that the tree decides to accelerate and change the lane to the left to overtake the other vehicle. Again, the decisions are based on relative speed and distance observations. We hope the small demonstration conveyed how we can make AI dependable through careful engineering. If you're interested in more detail, please refer to the papers. This work was conducted over 2 years with the help of students and researchers at FraunhoferIIS in Nuremberg. The core team, Lukas, Sebastian, Claire, Georgios, Axel and Chris. Thank you for watching. Cheers!